All right, so what we're gonna do is we're gonna go to logarithm and we're gonna talk about graphing of logarithm and we're gonna talk about where logarithm come from. So today's I think it will be a little bit challenging to think about. So you're gonna have to pay attention. So, oops, quick time. All right, so today we're gonna talk about why there is a logarithm. Um, But first of all, I'm gonna go to logarithm functions. I'm gonna go over extra properties in a second, but we'll talk about that part in a second. Okay. So one of the more difficult one is gonna be log of b to the bx is equal to x, and the b to the log b of x also equal to x. So ideally, these two things are inverse to each other, so they should cancel out completely and just left with the x. The same thing as this, b to the log b. They are the same base, so remember exponential and logarithm has some type of property that they can interchange, so they cancel out, or this cancel out, so left with the x. So this two property is gonna be pretty useful on some of the worksheet. Yes. I think somebody a question? Alexis? So you're raising your hand, right? No. Oh, I thought you were like this. Wait, what? No. You have questions? Okay, so just think about it. If I have log 2 of 2, right? What is log 2 of 2? That means 2 to the which power is 2, right? Yeah, so it's 1. So imagine there was an x, it'd just be 1x. Okay, so if you have log 2 of 2, that's equal to 1. We know that because that means 2 to which power. So for example, log 2 of 3, sorry, 8, that means 2 to which power is 8. That has to be 3, right? Does that make sense? Okay, so very, very intuitive. Now, just let you know that there's a property like this, you can actually cancel it. Now, let's talk about logarithm function versus e to the x. So first of all, we're going to want to go over y equal to 2 to the x, right? So we already know the graph looks like something like along the line, like say, exponential growth anchor point is this one, this one, this one, this one, this one. So it's gonna be like this, and the asymptote is gonna be like this. Okay. So is it possible for me to find inverse of y equal to 2x? So what is inverse of y equal to 2 to the x? So that means x equal to 2 to the y, right? But then you say, well, how do I get y by itself? I can't really get y by itself because y is exponents. Then what happened is we must have some type of a new introduction of functions. So this new introduction function is actually y equal to log 2 of x. Why is that? Because if I do a t-chart, right? If I say it's x, -2, that's going to be y is going to be -1/4. Not one, sorry, 1/4. At -1, it's going to be 1/2. At 0, it's going to be 1. At 1, it's going to be 2. And at 2 is going to be 4. So remember, for this particular one, it's going to swap. So x and y. What happened when x is equal to 1/4? Remember log 2 of 1/4? So 2 to which power is 1/4? -2, yeah. So what happened to 1/2? 2 to which power is 1/2? -1. What happened is 1. 2 which power is 1? And what happened is 2. 2 to which power is 2? 4, 2, right? So do you see this? It's a swap. So this is the inverse of this. Now, if I were to graph it in, guess what? Remember the symmetry line that we were talking about before? The inverse have some type of symmetry. Do you remember this? And the symmetry is going to have this point. I'm going to use red so that way you can see it. Because they're going to change. So 0, 1 becomes 1, 0. So 0, 1 becomes 1, 0. So that's the anchor point. And at 2 is 1, 2, so 2, 1. Does that make sense? And this is 4. And this is 1/2. And this is a 1/4. No, we're talking to get here. Does that make sense? So they kind of swap. But do you see this graph? Now, also this graph has some characteristic. Is there is a y vertical asymptote. So instead of horizontal asymptote, there's going to be a vertical asymptote. Do you guys see that? You have to memorize those two graphs. This two graph is very, 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 very important. Okay, those two graphs are really, really important. This is a graph that I need all the calculus students to know and actually understand. I'll show you on the Desmos. A Desmos is gonna give you a y equal to x. So y equal to x, like this. Y equal to 2 to the x. And the y equal to function logarithm. I don't know what logarithm is. Do you guys see logarithm? Yes, log base of 2 of x. And it looks like this. Where the hell are you? Okay, so now you see that this two graph, they have a symmetry, and this is the graph you need to know. So it doesn't matter if it's 2 to the x or 3 to the x or 4 to the x, they are very similar. So y, let's just show you y equal to 3 to the x. It's very similar. It has same anchor point, same horizontal asymptote. You see that y equal to function logarithm that to the 3 to the x. It's basically the same thing. So the only characteristic I need you to be able to graph is that anchor point, which is at 0, 1 for 2 to the x, and the horizontal asymptote. Everything else just kind of follow exponential growth. And same thing is decay. Same thing as the logarithm graph is have 1, 0 and has a vertical asymptote rather than horizontal asymptote. And the graph's gonna sketch this way. So you see that those two graphs are almost identical. So it doesn't matter 2 to the x or 3 to the x. Or matter of fact, you should know e to the x graph. Guess what? Y equal to e to the x graph is between 2 to 3 because we said e from yesterday is e to the x is right there. So do you see that? It's right in between 2 and 3. Do you see that? And what's the inverse of that? Y equal to natural log of x. Y equal to ln of x. And they are inverse to that. So do you see that this all the same relationship? that they have that exact symmetry, y equal to x. So we're going to change this to dotted line. That way you see that always the same symmetry. This is a two graph I need you to know for sure. Because you know natural log. What else do you know for the things? So right now we're just going to start it y equal to e to the x. Well, y equal to x, the same thing, right? It's no different. The same anchor point, same this, and the graph is going to be like something like this. And for the other one is same. Its same point is going to be like this. It's going to be like something like this. And this is same symmetry, same exact symmetry. So this is ln of x and y equal to e to the x. Now let's talk about domain of this. Domain is negative infinity to infinity. Is that okay? Range is what? What is the range of e to the x? What? Is it bracket or parentheses 0 to infinity, right? Also, when limits x approach to negative, this is the part that is going to be kind of confusing. Negative infinity of e to the x. What do you think is going to? If limit as x approach negative infinity to e to the x, what do you think is approaching? 0. Is that okay? Because why? Because this is approaching what? Huh? Oh. Later. Is equal to 0. Is that okay? Because limit x approaching negative infinity, it's going to become 0. Limit x approaching infinity. X approaching negative infinity. So x approach negative infinity. That when I approach negative infinity, it's going to plateau equal to 0. Also, ln of x is going to be domain. What's ln of x for domain? What do you think? Be careful. Domain is what? 0 to infinity. Range is what? Negative infinity to positive infinity. Okay? So today, I'm going to ask you to graph, hey, what's ln of x minus 3 plus 1? What does this graph look like? And what will be the domain and range of this graph? So can you graph ln of x this, and also what is domain and what is range? Ln of x minus 1. Remember, only follow certain thing. This is the part that we care about, is this anchor point and then vertical asymptote is moving. Everything else, I don't care. And also tell me what the vertical asymptote is. What's a vertical asymptote? And also anchor point. Do you guys graph it or no? Where's the anchor point at? So it was right here, right? It was like 1 comma 0, right? It's going which direction? Right, how many units? 3, and it's going to go up or down? So this is becoming the, so we're going to call this A. This is going to be A prime. Is that okay? Is that okay? And where the asymptote used to be at? X equal to 0, and it's moving which direction? Right 3, that's it. It can move up 3, up 1, doesn't make difference, right? So this is going to be an asymptote right here. So this is the new asymptote. So the graphs are going to be like something like this. Is that okay? Is that really difficult to graph? Who's that? Okay, I want you to graph negative ln of x plus 2 minus 1. Oh, I also need to tell you what the domain range here on this one. By the way, what's the domain of this function? 3 to infinity. And right? And range is what? And vertical asymptote is x equal to 3. And the anchor point is going to be at 4, 1. Okay, so pretty much those are the things I want to talk about. Also, another thing that, I forgot to mention on this one. So I want to mention one more thing. What happened when limits as x approach 0 from the positives of ln of x? What do you think? It's 0 to the right side. Anybody know you? 0 from the positive side. Raise your hand if you think you know. Cole? Goes to negative infinity. Because this graph is going this way, right? It's going to negative infinity. That's how you analyze in the graph. Yes. It doesn't touch the y-axis. Yeah, it's like an abyss. It's like it just fall. It just fall infinite. It's like a black hole. Except your grapes start at 0, doesn't fall. I can enter negative infinity on
you would if you could, though, right?
if you don't show up to school or my class. Okay, so this is just gonna fall like this. So it will not touch the asymptote, but we'll get very close to it, but it's gonna be going to negative infinity. Never touch it. You'll get really close to it. Just like you and that girl. You know Maddie.
Yeah, well, Maddie like knows you knew already.
Well, Maddie knew already, yeah.
You think Maddie blonde is good, or what do you think?
What is it?
Now we can call her a dumb blonde.
Yeah, I said that.
Oh no. All right. Anyway, does this make sense? Okay, so I want you to graph what happened with a negative ln of x plus 2 minus 1. It flipped which direction? Yeah, if it inverted that one, yeah. So I'm gonna grab the original graph so that way you can see it. So original graph is gonna be, this is ln of x, this is ln of x. So that way we can see what happened. So first of all, what does this do? Left or right? Left, 2, right? And this what? down 1. So left 2, down 1. So this is point, right? Now, instead of going this way, where would it go? It would go this way, right? It was inverted. So it'd be like this, right? Does that make sense?
Wait,
So this is the asymptote.
So just the X and Y
Switch at this point. It's just kind of inverted based on that particular anchor point. Swap. Huh?
2 points. The negative 2 and the -1.
Wait, Mystery, where'd you get the asymptote?
Where does that get?
The asymptote is from 0, and it's also moving left 2 units. Remember, this is the x is moving left 2 units. So the asymptote and anchor point move at the same time.
Wait, but that only happened.
It happened to natural log e to the x, all of them. E to the x also. Yes, Arthur.
So what do we do with the 2?
This means inside the parenthesis, that means always going to go according to transformation. If inside the parenthesis is +2, that means I'm going to go left 2 units. And the -1 is going to go down 1.
I know how to put it in the graph. But
So-
what do we do with those points?
So this anchor point is going to move here and move down. And that's the point. Now, since usually graphs like this, right?
It's negative.
But since it's negative, so it's going to invert based on that point. It's going to go like this.
How do you know the anchor point?
Anchor point is always this point. According to here, no, it's always a 1, 0. For this one or this one, 0, 1. So that's the graph you have to memorize. Okay. So now we know that domain and range and graph, which is nice. Sure. Now for this one, if you want to approach 0 from the positive, it's going to go past infinity because you go into the other way. Yes. So this point here, anchor point was right here, right? It's going left and down 1. Now, since usually this graph like this, now it's inverted going like this because it's flipped upside down.
Okay. If it usually go like that.
Usually go like this. Yes, usually go like this. So if I were to draw the this line, it would be look like this. But it's gonna invert based on this point, so it's gonna be going this way.
But the points don't like switch their X.
No, that point is based on transformation or natural log of x. So this is natural log of x. It's gonna go down. So let me show you here. Okay, let me show you on decimal. Maybe you're better. So let's just say if today we have ln of x is look like this. It looks like this, right? And we say it's going which direction? It's x plus 2. So we're gonna sorry, let me graph each one. So ln of x plus 2. So do you see that the point moving left 2, right? And it's -1, right? So -1 like this. So it go down 1, which is right here. This was right here. And then if we put a negative sign in front of it, it's gonna be this.
It's just regular. It's that anchor thing.
Anchor point is going
As
from
soon as you add the 2 and -1, it moves to that point, and then it has the same thing. Because negative inverts.
so this is the point where they invert it. So that point you basically just invert point. So it still have the same y-intercept, x equal to -2.
Okay, really stupid question. Why is it ln x?
It's called natural log, and we talked about yesterday. And what were you yesterday?
What? Actually, the doctor's thing.
I heard you at school.
Well, yeah, for fifth, sixth. I wasn't here for first, second, third, and fourth in your class. He's known this. You say it like it's a bad. Well, it's a bad thing. But you say it like it's not now.
Only the anchor point doesn't switch the X and the Y, but everything else, the X and the Y.
Yeah, so it's like your head. It's like this, right? If I'm going like this, right? My head is not gonna move. My head's gonna be here, and I'm gonna go like this. So my head doesn't move. My anchor point does not move. Everything else is gonna swap.
No.
Yeah, it's called anchor point for a reason. No, it does. Nobody ever, no textbook ever called that. The only reason why I give this lady, I usually watch like other teacher, how other people teach. There was a lady that is teaching somewhere. I think her website is called Purple Math. She called it anchor point, and I thought it was a good thing to teach students, so I steal it from her.
Like,
But I like to take other people's good parts, so I can use it for my class to get better myself. They don't ask you anchor point, but AP exam is very stupid. They're not gonna ask this detail. I ask this detail is because I want you to know further than what AP exam. The College Board right now, I'll make a TikTok video about it. College Board really hurts the math. It's really hurts math and pre-calculus especially because pre-calculus 3 years ago is about twice harder, but harder in a good way because it harder actually teach kids actually have to know a lot of detailed things. Now you don't have to know the detailed thing. You just if you're good, you take a good algebra 2 student, they can pass the AP pre-calc. If you give me a good algebra 2 student, even good algebra 1 student can pass that thing. Not good.
I was really good at Algebra 1. Don't even play.
Okay.
Ask Miss Jackson.
Oh Lord. Any question about this part? Now we know how to graph logarithm, and we know how to use this property. Today's work, you're gonna have this property. You're gonna have to use this property. Okay. Okay. Let's talk about more property. How much time I have? Oh, I have 14 minutes. A lot of time.
You can teach us 2 lessons.
I can teach you all the property today. Okay, so there is a property. I'm gonna ask you to come up with a property though. I'm not gonna give it to you. I'm gonna ask you a property, okay? So if I have log of 3 of 9 plus
Oh my.
log 3 of 27, okay? Yeah, log. So what is that equal to? Log 3 of what number right here? So, but let's say we don't know. Let's say we don't know. What's log 3 of 9? So I need somebody to raise your hand. What do you think? What's log 3 of 9? Arthur? Close. Let me ask Roger. 2. Yeah, so basically it's asking 3 to the what power is equal to 9. So that is 2, not 3. 3 to the... But Arthur, I'll let you try again. What's log 3 of 27? There we go. Now it's 3, so you're not wrong. Yeah. And then so 2 plus 3 is what?
5.
5. Okay, so log 3 of what number is equal to 5? Log 3 of what number is equal to 5? Log 3 of which number? What do you think this number is supposed to be? Yes?
243. Then just 9.
243? Okay, so good. 243.
Wait, I have a question. You don't have 9.
Ah,
I'm a genius.
you are a genius. Because what's 9
Live right
times 27?
now? Is that live?
Yeah, just for you.
I'm gonna make that my ringtone. I'm so serious. It's the greatest moment of my life.
9 times 27 is equal to, so if you don't believe me, 27 times 9, that's equal to 3, 6, it's 243. So technically, I will able to establish the new property. This new property is basically says if I have a log of some type of base of a number m plus log of the same base of n is equal to log base of what? Mn. Good. That's times each other. It could be the base 2. Long as they have same base, then it's fine. Sort of. You were not here yesterday, so it's kind of hard to explain to you. But I did make a video just for you.
Okay, I'll go watch.
That's nice to know.
It's my peak. I'm so serious. It's the most efficient I've ever been. On the toilet, it's like my brain sparks.
Okay.
That bullshit.
So this is called product property of logarithm. Now guys, can you predict what this is gonna be? Yeah, it's just dividing. So this property is called quotient property. Quotient property. So that is the second property that you're supposed to memorize. Now, it kind of reminds you of something though. Remember, a to the m times a to the n equal to a to the what? M plus n, right? No, plus, not times. What is a to the m over a to the n equal to what? A to the what? M minus n. So these two properties are correlated in that particular way. Now, what's the last property? Well, there's two more actually. So log b of m n like this equal to log b of m n. Now this one is very common use. This is called a power property. Yeah, n log b of m.
B?
Yeah. It's a b. It's always a b here. Here is 3. This looks like 3. This is just a b. B could be any number. B could be like 3 or 4 or 5. It's a b just as some type of constant. So this is called a power property. The last property is called changing of base. So you have log of b of m is equal to log of m over log of n, log of b, or equal to natural log of m over natural log of b. Now you're gonna say this property is called a changing base formula. Now, one last thing I want to put emphasis on this. One last thing I want to put emphasis. I will say it's this. All the log can be replaced with natural log. Do you guys remember natural log? What's natural log base? Natural log is equal to log base what? E. It's not log, it's actually log base of E. So these are interchangeable. So basically you can replace all the log right here. You can say that's natural log, that's natural log, that's natural log, that's natural log, this is natural log, this is natural log, this is natural log. Yeah, ln. Log base of E. And yesterday we talked about E, which is the Euler's number. Guys, That's re-emphasize. What is Euler number roughly equal to? 2.71828 dot 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 dot, and that no repeated number is also known as irrational number. It's actually known as one of the most beautiful number in the world.
Okay, explain that part. How
Okay, how can a number be beautiful?
eight is beautiful. You turn around.
Okay, so this is actually just a very interesting. So you can literally look it up. This the most beautiful equation in the world.
It can be put anywhere and it works. Like pi. Gold. Pi is really beautiful.
Okay, do you know what's the 5 most special number in the world? Can you tell me what's the 5 most special number
I
in
can
the
tell you
world?
one.
Which one?
0.
0. Okay, 0 is one of them.
I'm on fire today.
Okay, can you tell me another one that's most special number in the world?
1.
1. Man, you are 2 out of 5. Because the nice thing about 0 is this: anything times 0 is what? 0. Anything times 1 is what?
Whatever with time.
Yes, so that's why they are special number. Now there's 3 other number that you
I
guys
give
know.
up.
Huh?
Pi.
Pi, that's another one. There's 2 more. Well, there's E, good.
We cannot see anything right.
And there's the last number is what? It's I, you're right.
Those last 2 aren't even numbers, Mr. That's not fair.
It's an imaginary number.
Those are letters.
There's an
Math, not.
There's an imaginary number. So you can actually form an equation of all these 5 number, and that becomes a very difficult thing to prove at calc 2. End of the calc 2. Not even calc 1, calc 2. Okay? Yes. Okay, so the most beautiful equation in the world. So you can type in this basically look up, says the most beautiful
Game of the world soccer.
BEAU. Okay, the most beautiful equation in the world is e to the I pi plus 1 is equal to 0. And we learned all 5 numbers as of today. E to the I pi plus 1 is equal to 0. This is known as Euler's formula, or Euler's identity. Yep. E to the I pi plus 1 is equal to 0. Yeah, you should, because it could be those one day could be on your Quizable. Who's on Quizable? You are?
No.
Who's on a Quizable?
No,
Valerian could be on a Quizable. I feel like Valerian would be good at Quizable. Valerian, you're not in a
You know,
Quizable?
I'm really good at history. Like, whenever it's history play, I'm like this.
You should be on Quizable.
I really should. I'd be like, if you get one person that's good at every
Yes, Paul?
could you grab it?
No.
Even good at the subject. It's just
Well, the decimal not able to graph I. The decimal not able to graph I, but did I show you the graph of I look like in from Welch Lab from a YouTube video?
yeah.
Okay, it's you had to like put it outside the graph. It's outside the different dimension. Okay, so e to the I pi plus 1 equal to 0. We will revisit this if you come to Calc BC. BC is gonna be some of you guys. I think Gia, Shreya, Devin, Chase, and Cole is junior or senior? Junior. So you're gonna be an AB. So yeah, as far as right now, it's gonna be those people that unless you are sophomore taking pre-calc.
You're welcome.
Yes, good lord.
Wait, so all the
What?
all the software
The sophomore supposed to be end up to be BC Cal.
Senior.
Or unless you don't want to take. Huh?
Which is you.
No, that's not true.
How many BC classes do you have?
Two.
Surprising.
And actually, I only taught one group of student pre-cal 3 years ago, including Nellie Robinson, including Armin, including
Armand is genius.
including like Rylan, including so that group, 60% of that group is in my BC right now. Right now probably 42.
How many are
it's a,
white?
it's a large group, huh?
How many are white?
Not many. Maybe white percentage is about
Isn't McKenna and Josh?
the white percentage about in the smart class is usually like 18%, 18 to 20%. Yes.
Does that mean that e to the I pi is equal to -1?
Okay, so Julian said, does that mean e to the I pi equal to -1? Yes, absolutely. But if that, you're missing a very important number, 0.
Well, yeah.
Yeah. So this is the most beautiful equation in the world that it takes about 2 hours to prove to you that this is beautiful.
2 hours? Go, start. We'll be out of here by 2:40. Wait, no.
It's like the orchestra. Like here.